Okay, so we're going to look at the discriminant today. You did this last year where you were essentially told these three statements that your discriminant is the b squared minus 4ac. If that's greater than 0, then you have two real distinct roots. Distinct, another word for distinct being different. In other words, these 2 points would be your different roots. Or you were told that when b squared minus 4ac equals 0, there was one real root, which would be there. Now, if you also consider this to have had two real roots and the curve moves up, curve moves up, curve moves up, these two roots get closer and closer and closer together. So therefore you have equal roots. That's another way of saying it. So one real root is equivalent to saying equal roots. And then for this one, if you had b squared minus 4ac is less than 0, in other words, when it was negative, there were 0 real roots, okay? In other words, it never reached the axis or crossed the axis. So, taking it further higher, you're going to use that information to do a bit more problem solving with it. So, we're going to find the value of k when x squared plus 6x plus k equals 0 has equal roots. So here we've got an unknown number, and we need to work out what that is so that this statement here will give equal roots. So when this gives equal roots, b squared minus 4ac equals 0. Okay, so therefore I need to basically essentially find out for what value I'm going to put in here is going to make this equal to 0. So just a wee recap, you can do this if you like, you don't have to do that, but I'm going to state what a, b and c are down at the side. So a is 1 because there's 1x squared, b is the number of x's in the middle and there's 6, and c is the number on its own, or in this case a letter k. So I'm going to sub these three bits of information into this. So I've got my b squared, so in this case I've got 6 squared, take away 4 times 1 times k. And I know when I've got equal roots that equals 0. So working this all out, I've got 36. 4 times 1 is 4, so 4 times k is 4k, and that equals 0, and then it's just simply a case of solving that for k. So take the 4k over to the other side, leaves you with your 36, and then divide by 4. So k equals 9. Okay, right, that's the first easiest example. We're going to look at 3 more. Okay, so we're going to find the value of k when x squared minus 2kx plus 9 equals 0 has equals roots. So, same thing. When I've got equal roots, I know that b squared minus 4ac equals 0. I'm going to just, you don't have to do this, but if it helps, do it. Just write down what a, b and c are. So a is the number of x squared, so in this case it's 1 again. B is the number of x's, so in this case it's minus 2k. And C, it's 9. Okay, then you're going to substitute these three bits of information into here, then you're going to solve it. So I've got minus 2k squared, take away 4 times 1 times 9 equals 0. Alright, I'm going to go on and solve that. So minus 2k squared, so minus 2 times minus 2 is 4, k squared, and then 4 times 1 times 9 is 36, equals 0. Now, you're then going to go on and solve this one. This is just going to be a quadratic, so I'll take a common factor first. So 4, that leaves me with k squared minus 9 equals 0. And then I'm going to factorise that by difference of squares, so get plus 3, minus 3, and then each bracket equals 0, so k equals minus 3 for that one, and k equals positive 3 for that one. Okay? Right. There are other ways of solving this. Some people would take the 36 to the other side to get 4k squared equals 36. Divide them by 4 to get k squared equals 9, and then when you square root, you get plus and minus 3. So if you're not fancying your factorising with your difference of squares, you can do it that way if you want to. Right, example number 3. Finding the value of k this time when I've got x squared equals 2kx minus 5k has equal roots. Now, if we can go back up to the example above, this must equal 0, okay, in order for you to do your b squared minus 4ac. So, this must equal 0, okay? So therefore, x squared equals 2kx minus 5k must equal 0. So I'm going to take everything over to join the x squared. So we've got x squared minus 2kx plus 5k equals 0. And then I can go on and solve it just like I do the other way. So I'll do b squared minus 4ac, talk about my roots and they're equal, so then this equals 0, that's very important. And then you've got a equals b equals c equals, right? And a this time still 1x squared, b is minus 2k, and c this time is 5k. Okay, so subbing that in, you get minus 2k squared minus 4 times 1 times 5k equals 0. Squaring that out, you get minus 2 squared is 4, k squared is k squared, then you got minus 4 times 1, which is still minus 4 times 5k is minus 20k equals 0. Right, quadratic equation this time, we have to factorise. So we're going to factorise it by taking a common factor first of all. So common factor is 4 and k. So therefore, dividing by 4, taking away the k, you're left with the k for the first term. Dividing by 4, you're left with 5, and you've taken the k away. Now each k, or each expression with the k is made to equal 0. So I've got 4k equals 0, k minus 5 equals 0. Divide by 4, you still get k equals 0. Shift the 5 over, and you get k equals 5. Okay, so final example, we're going to look same sort of thing. So we've got finding the value of k when x plus 1, x minus k equals 0 has equal roots. So when we start talking about the equal roots, we're doing the b squared minus 4ac, but this is not in the form where I can just lift the a, the b, and the c, so that I can do the b squared minus 4ac. So I'm going to have to expand the brackets and write it so that I can lift the a, the b, and the c. So if I take the bracket and I expand it as I normally would, I would get x squared plus x minus kx minus k equals 0. And then it's almost there, but I want to lift the a, the b, and the c, but there are two x terms for the b. So I'm going to take a common factor of the x. So I have x squared plus, I've got 1 here, and minus k here. So I can write it like that, minus the k equals 0, and that therefore allows me to put the b terms together. So here, a equals 1, b equals 1 minus k, and c equals minus k. Okay, so sticking this into b squared minus 4ac, and I know that that equals 0 because we've got equal roots. So then I have 1 minus k squared minus 4 times 1 times minus k equals 0. Expanding this and then solving it, so you should then get 1 minus k, 1 minus k, that ends up being minus 4 times minus k is plus 4k equals 0. So this, multiplying this out and tidying it up, gives you 1 times 1 is 1, 1 times minus k is minus k plus k squared plus your 4k at the end. Tidying it all up, you get k squared. I've got 4k minus 2k, which gives me 2k, and I got my 1 stuck at the end. Alright, now I can got this to solve, factorise it, you get k plus 1, k plus 1, or you can also write it as k plus 1 squared, so therefore k plus 1 equals 0, so k is equal to minus 1. So essentially the solving of this just comes down to using all the skills you did last year, essentially. Alright, thank you very much.